Hello, can you hear me there?
I sir.
Can you hear me?
Yes, sir.
All right, let's start. If the screen is not clear, you just let me know.
Yes, sir.
All right, so this was our session for physical science.
So I can't
So
see anything on the screen.
you can't. Anything?
No, sir.
Anything so far?
No, sir.
You let me know. Yes. Just let
Yes, sir.
How about now?
Yes, sir. It's now fine.
So let's start. For 2.1, it's saying where electrons, a small metal sphere A carrying a charge of -9, -4 nanocoulombs is placed on an insulated stand where electrons added removed from the sphere. What was your answer? What was your
Sir, I can't see anything.
answer again? How about now?
Still nothing, sir.
I think it's the network.
Yes, it's now fine.
So we are saying were the electrons added or they were removed. If
They
you
were added.
see negative, we said it means what? Did it gain or lose electrons?
Gained.
Gain. So which means that is the one which I was telling you. Sometimes they don't write like -4 times 10 to the power -9 coulombs. So they can replace this times 10 negative power -9 by just saying -4. Then n, that small n, represents times 10 to the power -9. And they do like this. So that is the one which I was telling you that other day, that sometimes you are given like this, or sometimes you are given like this.
Yes, sir.
So here electrons were added, which is correct.
Yes, sir.
So that one is correct. Electrons were added. So your answer for this one, you said added, which is correct. Which is correct. They were added. All right, let's go to the next one, which is asking us about how does the number protons, how does the number of protons compare with the number of electrons in sphere A? Write down less than, greater than, or equal to. So your answer was what? So we are talking of how does the number of protons compare to the number of electrons. If an atom is neutral, it means the number of electrons and the number of protons are what? Hello?
Hello.
Yes, I'm saying in a neutral atom, this is a metal sphere. If it's neutral, we mean that the number of electrons, they are -4, So if this had gained, which means the number of electrons have increased and the number of protons. Because in a neutral atom, the number of protons, they are equals to the number of electrons. When an atom is neutral,
Yes, sir.
the number of protons is equals to the number of electrons, so that it is neutral. But because this one is gained, that's why it's negative. So the number of protons are going to what? To increase. So when you are talking of protons, and when you talk of electrons, so in our case, the number of electrons will increase. So in other words, the number of electrons will be more than the number of protons, because what we have gained electrons. So they are now more.
Yes, sir.
So how does it compare? Is it less than, greater than, or equal to? So the answer will be greater than. So the number, how does the number of protons compare with that, with the number of electrons? So the number of protons will be less than, isn't it?
Yes, sir.
Because what has increased are electrons. So the number of protons are going to be less than the number of electrons. So the answer there was less than.
Yes, sir.
This one, less than. The number of protons are going to be less than. All right. Sphere A is negative charge. Negative charge indicates many electrons. Yes, which means gain of electrons. So what was gained was the electrons. Yes, it's correct like that. Let's continue to the next one, which is if 10 to the power 3 electrons are now added to sphere A, calculate the new charge of sphere what? A. Just like what I told you the other day, when you're using formulas,
Yes, sir.
that is the same principle that we are going to apply here. So you need the total charge that has been transferred. You need the total charge that has been transferred, because here we are only told that the number of electrons that have been transferred is 10 to the power 3 electrons, but we don't know what was the charge which was transferred.
Yes, sir.
We don't know the charge which was transferred. So that formula, what does it say, which I told you to write in your book for Q?
For Q, sir.
The formula which I told you, Q is equal to what? When you're writing the exam test for this term, we did this problem. When I was telling you, you are given a formula which is telling you charge, or the number of is equals to what, or the number of electrons is equals to what. There were two formulas which I told you. For Q new charge, which was Q1 plus Q2 over 2. I gave you this formula, the first one. And then there was another one where we were calculating the number of electrons transferred. The number of electrons transferred, where we said is the total charge Q over what?
Over 2.
Over
2.
So how were you writing a test? yet you don't know these formulas. How did you write the test? Yet you don't have these formulas and you can't recall what you already written. Isn't this is the last section where I was teaching you before the test, when I was telling you the total charge. If you want the new charge on each sphere, this is the new charge on each sphere, which is Q nu on each sphere, which we said is equals to Q1, the charge of sphere 1, Q2, which means you are adding, plus the charge of sphere 2 when they come into contact. Then you divide both of the charges by 2. Then you get the charge after contact. Then we said the number of electrons which are going to be transferred, Ne, number of electrons, is equals to the charge which was transferred during contact. How much charge was transferred? Where we said the final, which is this Q nu minus the initial, divided by the charge Q on an electron, which is negative. This one is the Q which we are talking about, QE, the one which you wrote here, charge of an electron. So these formulas, you must be having them. If you are having a physical science book and you are not having these formulas, what are you working out? Because these formulas, we discussed them when you're writing, and you said you are writing in a book. Now I'm asking the formulas. You don't see them. So first, we have to calculate the charge which was transferred. So what we know is the number of electrons. So what we know, we were told that this is 10 times 10 to the power 3. 10 to the power 13 electrons was transferred, Ne. From our equation here, what we are given, from the formula, we need to know Ne small letter E is equals to Q over the charge of an electron. So from here, what you are given is 10 to the power 13. That is your Ne. Okay?
Yes, sir.
And then this, you know it from the formula sheet, QE, which is negative 1,602 times what? 10 to the power negative 19. Then you can calculate the number of electrons, I mean the charge, which was transferred to this sphere A. So calculate for me what is Q. Calculate for me what is Q. When you are done, you tell me, calculate the Q using the information that we are able. Calculate Q first. Because the question says, what is the new charge of sphere A? So we are going to use that formula, new charge, Q nu is equals to Q1 plus Q2 divided by 2. So in the first place, what is this charge which was transferred by 10 to the power 13 electrons? So here what you were given was number of electrons, Ne. So you were supposed to calculate Q, the big Q. So calculate that Q, tell me what I get.
Yes, I'm still calculating.
Are you done?
No, sir.
Are you not having a calculator?
Yes, sir. I was still typing it in.
What is the which you are getting on your calculator? Isn't it your which numbers did you multiply for you to get Q? Isn't it you want to make Q subject of the formula? Now with your mathematics will come. How do you make Q subject of the formula? Q is equals to what? The big one. Q will be equals to what? N multiplied by QE. So what do you get when you multiply those two? The number of electrons you know is 10 to the power 30 multiplied by the QE. What answer are you getting? That's what I'm asking.
Say I got 0,0000016.
Now put that answer in standard form. Standard form, like what we were doing in maths, the number must be between 0 and 9 times 10 to the power something. Standard form, your number must be between 1 and 9. Then you are writing it as times 10 to the power. I don't want to hear those zeros. Put that answer in standard form. Now you should be knowing how to put an answer in standard form. Put that number in standard.
Yes, sir. Say it's negative 1,6 multiplied by 10 to the power of negative 6.
By 10 to the power
Negative 6.
negative 6.
Yes, sir.
Yes, that is the answer. So that Q which you are looking for, now you know that Q which you are looking for is that answer which you have just given me now. So, which means we now have our Q which we're looking for which is equals to -1,602. Say times 10 to the power 1.
-6.
-6. And remember, the unit, the C.
Yes, sir.
Right. So calculate the new charge on sphere A. So what is going to happen now? If I transfer these electrons, what will be the new charge on sphere A? What do we do?
So say the Q that we just got now, does it fall under the Q1
Remember,
plus Q2 over 2?
This is the electrons that were added, which means you are adding when you gain. In other words, this Q which we are talking about, when we say Q new is equals to Q1 plus Q2 over 2. So this will be the new charge. After you have added another charge, isn't it?
Yes, sir.
So what will be the new charge? Sphere A. What are we adding and what are we going to divide? What was the original charge?
The original charge of sphere A?
Yes. -4 nanocoulombs.
Nanocoulombs.
So I told you nanocoulombs, you convert times 10 to the power -9. So that's what you are adding now, plus. So in other words, your Q new is going to be this number plus what we got here, plus a negative. So we are adding a negative to a negative, you get a negative. Okay.
Yes, sir.
Yeah. So let's see what you are going to get there. We are adding those two numbers. Q1 is 4 times -4 times 10 to the power -9 coulombs, plus that one, negative again, then you divide by 2. What are you getting?
Yes, sir. Can I please quickly do it? So should I convert it to standard form?
Yes.
So I got -2 to the power, -2 multiplied by 10 to the power of 9.
After you have divided. It was after you have already divided, or before you divide by 2.
Yes, sir. Yes, sir. Yes, sir.
After you've divided by 2. Your answer is negative
2 multiplied by 10 to the power of 9.
negative 2
multiplied by 10 to the power of negative 9.
coulombs is the unit.
Yes, sir.
So that is the approach we use, not what you did here. Here, what happened here? What were you doing? Where did you get 10 from? 10, you got it from where?
Oh, I took it from the 10 to the power of negative 10 to the power of 13.
10 to the power of 13. This one.
Yes, sir.
And then where is the power 13? I don't see it. Where is the power 13? Oh, that one, that is not the correct one. So let's go to the next one, which is the one for calculating, like what was when you're preparing for exam. So we said the principle of conservation of charge. What does it say?
The net amount of charges in an isolated system remains the same.
But there's a statement that you are leaving there. There's a statement that you are leaving, which is very important, where you say the net amount of charge, not of charged. Net amount of charge. Of an object. Yes, net amount of charge of an object in an isolated system remains the same.
Yes, sir.
What about the physical process? In any physical process, you didn't include that statement. Why? Remember, when the charges are in contact, it's a physical process, isn't it?
Yes, sir.
So you must include that statement. It's also important. Right. So when the spheres touch, the charges restarted. What? Said when the spheres touched, the charges restarted themselves. What is it that you wanted to say?
Oh, I wanted to say they share their charges.
When spheres touched, it implies that when they are in contact, there is transfer of electrons, isn't it?
Yes, sir.
When they come to contact as a result of positive and negative charge. Like in this case, we are having a positive and what? Negative charge.
Charge.
So electrons, these charges first, they attract because a positive the negative attract. So there is attraction, that is number one. That's why they come into contact. So there is attraction of positive and negative. So here, this is the attraction, they come together. When they are now in contact, electrons, there is electron transfer. That is the sharing which we're talking about.
Yes,
So
sir.
we have electron transfer.
Oh, electron transfer.
When they are in contact, until all the charges, there's electron transfer until all the charges have equal charges. So the charges are now the same. So when charges are the same, what happens? They repel. For example, this is positive, positive. That's why there's a repulsion now. They separate.
Yes, sir.
That is what is happening. There's repulsion. Electrons, the charges, they separate. So you don't mention of restarting like what you are saying here. There is no terminology which we are looking for. So we are looking for attraction, positive, negative. We are looking for sharing or transfer of electrons until both spheres has an equal charge. Yes. Then you talk of repulsion. So if they have an equal charge, what happens? Then they get separated because positive charges or same charges, they what? They repel, isn't it?
Yes, sir.
That's how you're supposed to explain it like that. Let's go to the next one, which is calculate the number of electrons. Calculate the number of electrons transferred between the two spheres during contact. So here you are just repeating that process which we did. So let's see how you did it. So first we said what you do, you calculate the why did you leave this one blank? Huh?
I said, give me a challenge.
But this is what you saw even in the exam, you did not write this one. You left it blank. That's what it means. We're doing the whole 2 hours, but when it comes to the test, you leave it blank. So what is the purpose of these online classes? Yet you are leaving answers blank. So calculate it now. Now you know how to do it. Tell me what is the answer.
Yes, sir.
So we are having two charges. We are having two charges here, which are positive 4 and negative. So first, when they come into contact, we are going to look for the what? Q nu. Can you see the Q nu?
Yes, sir.
Q1 plus what?
Plus Q2.
Over
2.
2. Then you look for the charge that has been transferred. The charge that has been transferred, which means that Q nu minus any of these ones, so that you see the amount of charge that has been transferred. So let's do that one for now. Let's calculate Q nu. After you divide by 2, you tell me what are you going to get. And remember, these numbers are times 10 to the power negative 6. So
Yes,
let's
sir.
add. Let's calculate Q nu. Tell me what are you getting. Q. Formula is there. So let's calculate Q. These are marks that you leave blank. If you are leaving it blank now, which means if in the test you left it blank. So I'm giving you time to calculate.
Yes, sir. Yes, sir. Say I'm done.
What I get?
I got -1 multiplied by 10 to the power of -6.
That is your what? Is it your Q1 plus Q2 or is the Q new?
Q1 plus Q2 over 2.
Over 2?
Yes, sir.
And then now we need to calculate the amount of charge which was transferred. So that Q new is your Q final minus the Q initial. How much charge was transferred? Calculate the difference. That answer that you got minus any of those which are there. Subtract any of those which are there. Then you see which one.
Yes, sir.
Right. How much are you getting?
Yes, sir. Say I'm done.
So you said your Q new is how much? Before we go any further, Q new is equal to how much?
-1 minus multiplied by 10 to the power of -6.
-1 multiplied by
10 to the power of -6.
coulombs.
Yes,
Then
sir.
what is your change in Q? That formula which I said change in Q. That formula, change in Q. You are talking of the charge which was transferred. So this is your Q new. You must write these formulas down. Q new minus Q initial. So what is your change in Q? It's Q new minus the initial. What are you getting? Let's start with the first one.
Yes, sir.
-1 times 10 to the power -6 minus plus 4 times 10 to the power -6. What do you get? If you use this
Yes,
charge,
sir.
what are you going to get? If you are using, let's say, this charge, what do you get? As your change in Q. In place of Q initial, you put this charge. What do you get? If I put a 4 there, which is a positive. So I'm having a -1 I'm having a -1 minus a positive. What am I going to get in the end? +4, -1. What do I get at the end? My change will be equals to what? -1 times 10 to the power -6 minus +4 times 10 to the power -6. What answer you get?
-5.
It's what?
-5.
-5 times what? What is your answer?
Times 10 to the power of -6.
Yes, it's not only -5. It's -5 times 10 to the power -6 coulombs. You also do the same to verify your answer. In place of Q, now you don't put 4. Now we are putting -1. That is my new charge. Then my initial charge, I'm not going to use this one 4. I'm going to say my initial charge is 6, but it's a -6. What answer are you going to get if you use it like this? What answer you get? What answer you get? The matter of just putting everything on your -1 times 10 to the power -6 minus 6 times 10 to the power -6. What do you get? Then the calculator will give you the answer straight away.
5 multiplied by 10 to the power of -6.
It's what?
5 multiplied by 10 to the power of -6.
Yes. So which means the other one is having a positive, and then the other one is having a what? A negative, isn't it? Can you see what is happening? Yeah. So which means the other one gained, and then the other one lost. But the number of electrons that were transferred were 5 times 10 to the power -6. So our question now is asking us, how many electrons were transferred? We are not interested in the charge. How many electrons were transferred? That is the question which we are asking. The question wants us to find number of electrons that were what? Transferred. So now we know that the change in Q, this is the number of electrons transferred, is equals to the Q new minus the Q initial. So we found that number to be -5 times 10 to the power -6 coulombs. So using the formula, number of electrons transferred is equals to the charge Q. This charge, which means which we are talking about the change Q, change in Q, this one, over the charge of an electron, over the charge of an electron. So now we want to calculate this number, Ne. We know this one, we know this one. So calculate. Charge of an electron, negative, times 10 to the power -19. Charge which was transferred, that is the charge. So let's substitute and get the answer.
Yes, sir. Say I got 3,125 multiplied by 10 to the power of 13.
You got what?
3,125 multiplied by 10 to the power of 13.
3,125 times 10 to the power
13.
18 electrons. So these are number of electrons. Always positive. When you divide negative by negative, you get positive. That is the trick. So can you see how we are solving these problems?
Yes, sir.
Yes, but I'm very sure in the test you left this one out. The same way you left it here. You left it out. And it came and you left it. So you are not supposed to leave it like that. So okay.
Yes, sir.
All right. So master it. Tomorrow we'll continue with maths on this one. So
Yes,
just
sir.
revise this one, recap everything what we're talking about. Then you recap everything like
Yes,
what
sir.
we're discussing. I will share the recording. Okay.
Yes, sir. Thank you, sir.
All right.